Hello viewers, today we will solve a problem based on a chopper fed DC drive. So our question is a chopper fed DC motor drive operating in quadrant first with source voltage of 220 volt, chopping period 2000 microsecond, on time 600 microsecond, and load circuit parameters are R is equals to 1 ohm, L is equals to 5 millihenry, and motor back EMF E is equals to 24 volt. Find the followings: minimum, maximum and average value of output current, operating duty cycle and efficiency of the drive. So we have given the Vs is equals to 220 volt, chopping period is given as 2000 microsecond, we can write it as 2 millisecond, and T on time is 600 microsecond or 0.6 millisecond. The load is R load is 1 ohm and inductance L is equals to 5 millihenry, and EMF back EMF induced is 24 volt. Now we can calculate, let's calculate the time constant. First let's write it as A part. A as the time constant, armature time constant is tau A is equals to L divided by R. So it is 5 millihenry divided by 1, it is 5 millisecond. Now we can calculate the duty cycle. So B part is duty cycle. So D is equals to T on time divided by T. So it will be 0.6 divided by 2, it will be 0.3. Now we will move to the first part. So our first part is maximum, minimum and average value of output current. So formula for the maximum current, first maximum current, we will find the maximum current. So I max is equals to Vs divided by Ra, 1 minus e to the power minus T on divided by tau A divided by 1 minus e to the power minus T divided by tau A minus E divided by Ra. So put all the values. I max is equals to Vs is 220 volt, so 220 volt, Ra is 1, so 1 minus e to the power minus T on time is 0.6 millisecond and tau A is 5 millisecond, so 1 minus e to the power minus T on time is 2 millisecond and tau A is 5 millisecond. So minus E is 24 volt, Ra is 1. So solving all these values, we will find I max is equals to, let it write as on solving this numerator and denominator, the value will be 0.33 minus 24. So our answer will, I will write it directly, so answer will be 48.6 ampere. So our maximum value of current is 48.6 ampere. Now we will calculate for the minimum current. So for the minimum current, I min is equals to Vs divided by Ra e to the power T on divided by tau A minus 1 e to the power T divided by tau A minus 1 minus E divided by Ra. So put all the values. Vs is 220 divided by 1 and E is to the power 0.6 divided by tau is 5 minus 1 divided by e to the power 2 divided by 5 minus 1 to minus e is 24 divided by 1. So on solving this, our value will be 32.76 ampere. So our maximum current is 48.6 ampere and the minimum current is 32.76 ampere when the DC motor is working in first quadrant. So minimum current is 32.7 ampere and maximum current is 48.6 ampere. So the average value will lie somewhere in the middle of the maximum and minimum current. So solve for the I average value. So I average value is equals to d Vs minus E divided by Ra. So d is duty cycle. So put the value. D is 0.3 into Vs is 220 volt minus E is 24 divided by Ra is 1 ohm. So our value will be I average will be 42 ampere. So our answer I average is in the middle of these values. It is 42 ampere. So it also proved that our answers are correct. Now move toward the second part, which is operating duty cycle and efficiency of the drive. So operating duty cycle, second part is operating duty cycle. We have calculated it early. Operating duty cycle. So we have calculated it before, which was T on time divided by T, which was 0.6 divided by 2, it is 0.3. Now we have to calculate the efficiency of the drive. So efficiency, what is efficiency of a machine? So for the motor, it is the load output power at load and divide by input power to the motor. So P output, first we calculate P input is equals to Vs into I average. So it will be 220 into I average is 42 ampere. So it will be the output input power will be 9240 watt and output power will be E into I average. So it will be equal to, this is E is 24 volt and it is 42 ampere. So it will be 1008 watt. So efficiency will be output divided by input. So 1008 divided by now 9240. So it will be 0.109. By multiplying by 100, our efficiency will be 10.9%. So it is the efficiency of our motor on supplying voltage. So thank you. Please like and subscribe to the channel.